Round 2, Speedup Concept. From this name, you can see we try to improve the performance of a computing task, of some general computing task. All right, so let's look at this concept first. What is the speedup concept? We need to define a measure for the speedup. When we improve the performance over a computing task, how to measure speedup? Yeah. Suppose we need to apply a new technology on a program. Yeah. Before we apply the technology, we have some performance measure, right? Then, after we apply the new technology, the performance should be improved. Then we need a measure for the speed up, this concept. All right, so let's see the measure first. Speed up concept, the measure. Measure for performance improvement. Yeah. So that is the speed up. Okay, the meaning. Yeah. But next question is, how do we define this measure? Okay. All right. To improve the performance of a computing task, a new technology is applied and the performance is enhanced. Now, definition. Yep. Because there are two different performance measures: before improvement, after improvement. Okay? Yeah. Then, can we use the ratio of those two numbers to define our speed up? Right? Yeah. So that's the natural way to define speed up concept. Yeah. Let's look at the formula. Speed up equals performance with enhancement over performance without enhancement. Yeah. So that's natural. Performance with enhancement, that should be a relatively larger number, right? Yeah, because with enhancement, with new technology enhancement, the performance number should be bigger. Yeah, bigger means faster, right? Yeah, when we define performance measure. Yeah, over a smaller number, performance number without enhancement. So this ratio should be greater than 1. Then you have improvement in the performance, should be greater than 1. Yeah. Speed up. Yeah. From this name, we expect this number to be greater than 1. Then speed up. Right? Yeah. Otherwise, you don't have speed up. Yeah. Or another. Yeah. Because remember the last time in our discussion, the performance measure we define using that reciprocal of the execution time, we feel it's problematic. It's problematic. That means it is very easy to misuse that definition. So many times we try to avoid it. Okay? Although here it makes sense. Yeah. Here, the way we are using here makes sense. It's correct. Why? Because we are talking about same computing task. Same computing task. When we apply these performance measure on the same computing task, then we do not misuse it. Yeah. It's fair. It's a fair comparison. We do not misuse it. So it's okay. Yeah. All right, but we like to use the execution time. Yeah. Definitely on the same task, execution time. But this time, because of that reciprocal relationship, right? Reciprocal. So the older time without enhancement, older time, before we apply the new technology, without enhancement, that will be a larger number. Older execution time will be larger, yeah? And the new execution time will be smaller, yeah? So we do that ratio, and we know it is greater than 1. So this is the definition. Okay? So with this definition, then we need to derive speed up formula. All right, so our next half slide, we will derive a formula of speed up. All right, based on the definition, speed up overall equals T old over T new. Here, I do not want to write, this many words, right? In our definition, we can write in that way, but in our formulation, we want to use concise, simple expressions. So here I use T old over T new, so you'll understand the meaning. Okay. Then we need to describe the situation, details, on what is the typical situation in a computing task. So we describe that part. All right. Here I draw this line segment to represent the whole computing task. More specifically, execution time of a computing task. Here we use execution time, okay? More reliable, right? So here you can see I like to use the execution time version in our analysis because it's more reliable. Here I do not use the performance-based analysis because it is very easy to misuse it. Yeah, so you get the idea here. Yeah. All right. Then we split a typical computing task into two parts. Yeah. The first part, the part that can be enhanced. That can be enhanced. Because in a typical situation, we cannot enhance the whole part. No, almost impossible. It's impossible to enhance the whole part in a computing task. So the more realistically, we can only enhance a portion of it. Okay, part of it. Yeah. So for that part, first part, then the remaining will not be enhanced. Only these two parts. Yeah. Then we need to use a number to describe these two parts. So the fraction of enhanced part, here I use F sub En. Okay, so you understand the meaning, F, fraction. Okay, so the fraction of the total execution time for the enhanced part, Fen. Okay, fraction number. Yeah. Then the remaining just 1 minus Fen. Okay, yeah. So that's the first assumption we need to use. Fen, the fraction of the enhanced part. All right. So then we need another assumption. Okay, yeah. All right. Here, so let's draw the diagram. Draw two different states. We look at two different states. Before enhancement, we have TO execution time. After enhancement, we have T new in execution time. All right. All right. Yeah. So that corresponds to the speed up overall, right? Speed up overall. Yeah. But now for this particular enhanced part, there is some improvement, right? Because after we apply a new technology, this part can be improved, but that part cannot be improved. Okay? But this part can be improved. How much it can be improved, right? We want to know how much it can be improved. So we need another measure for it. Speed up, En part. So here you can see the speed up. Two different speed up number. One overall, another only the En part. Okay, and we need this number. Okay, all right. Now let me summarize. Yeah, because for this video, we will not get the formula of speed up. We just do some analysis. Okay, yeah, understanding. Next video, we will derive that formula. Yeah. All right, so now let me do the summary on our current situation. Yeah. All right. What are knowns? What is the unknown? The unknown, speed up overall. So that's our goal. Go find the speed up overall. What is the known? You need to have some known information. Two numbers we need in order to determine the overall speed up. First, FEN, the fraction of the enhanced part. Second, speed up EN. Oh, I also call it a local speed up. Local speed up. Yeah, because only local part, not global. Yeah, so this is the global speed up. Yeah. So we need to know the local speed up and the fraction for the enhanced part. Then we need a formula to calculate the global speed up. All right. So that's what we are going to do in our next video, C.3. Yeah. All right. So let me stop here for